Hello, friend. I'm glad to share this quiet with you. In the dim hush, pillows remember your shape, and your breath settles into a slow tide, in and out, with nothing to prove. Tonight, we wander into a colder kind of comfort, the frozen cosmos, where cold isn't a bite or a sting, but the simple absence of heat, the gentle slowing of atoms when they run out of reasons to hurry. We'll trace that stillness from frost on a window to the deep night between stars, where motion grows small and time seems patient. No rush. We'll let the mind drift like snow in a street lamp, pausing with the tiny dances of molecules, the quiet glow left over from the beginning, and the places where space itself feels almost at rest. If this soft stretch of night helps you loosen your grip on the day, a light tap to like and a quiet subscribe can guide other weary travelers here, only when it feels easy. For now, lengthen the exhale. Let warmth gather where you lie. Thoughts can float like pale flakes and settle wherever they wish. Close your eyes. The universe is cooling its music, and we'll listen together, unhurried and warm. Cold feels like something your skin already understands without asking permission. Step outside before dawn in January. Breathe in that thin, glassy air. Brush your fingers across a metal buckle that forgot the sun, and the body names it instantly. Under the quiet light of science, though, cold isn't a substance that arrives. It's what remains when heat has wandered off. Heat is motion, atoms, and molecules, nudging, spinning, quivering in place. When their dance is generous, we call it warm. When the steps grow small and the music slows, we call it cold. Imagine shrinking down beside a curl of steam above a teacup or the still air near your pillow. You'd find a crowd of tiny travelers bumping and vibrating, never quite motionless. Only at a boundary we call absolute zero would that jittering reach its minimum. Even there, a faint quantum restlessness survives, like the last glow in a wick that refuses to go entirely dark. Think of cold as a finger that gently eases down the pause button on this microscopic concert. Not silence, just a softer volume. To keep track of that softness, we borrow scales. In Celsius, water's familiar markers anchor the story. Ice at 0 degrees, boil at 100 degrees. Fahrenheit, fond of kitchen talk and weather reports in the United States, puts ice at 32 degrees and boil at 212 degrees. A legacy from Daniel Fahrenheit's experiments with brine and body warmth. For the cleanest bookkeeping, physics leans on Kelvin. It begins at absolute zero, where thermal motion is as low as nature permits. 0K equals 273.15 degrees C, which is 459.67 degrees F. Starting from zero keeps the arithmetic honest. Temperature becomes a measure of energy that only climbs, a ruler laid along the road from near stillness toward lively disorder. Numbers are useful. Skin is persuasive. The body doesn't read temperature as a single figure, so much as a story about losing heat. A cool room doesn't attack you with coldness. Your warmth simply leaks into the air, into the chair, into anything that's cooler and hungry for energy. Humid air and damp fabric carry that heat away faster. Wind brushes off the thin, protective layer of warm air that clings to your skin and hurries the loss. Meteorologists call the feeling wind chill less a mood than a rate, the speed at which your warmth is leaving. The nerves that report this are tuned for survival, not precision. Fingers may complain loudly, while your core remains calm. Bodies differ, too. Some people carry more insulation. Some recruit brown fat that burns to make heat. Some simply learned long ago to trust a steady cadence of breath while the weather passes over them like a slow wave. Cold can sting in ways that resemble fire. Press bare skin to dry ice or a winter pole, and the pain arrives with a bright clarity. Water in cells can freeze and swell. Sharp crystals can tear delicate structures. Frostbite and burns are mirror injuries meeting in the middle, one from heat racing in, one from heat racing out. The trick, as always, is pacing. Give the body time to trade energy with its surroundings, and it often forgives. For all its bite, cold is an instrument we've learned to play softly and well. Food rests longer under its blanket. Vaccines wait safely for their moment to help. Chemical reactions hesitate, letting us keep flavors, medicines, and fragile compounds intact. In hospitals and laboratories, careful cold buys time. Tissues cooled before surgery, cells sleeping in liquid nitrogen, seeds saved for futures we can't yet imagine. Go too fast or too far, and ice crystals carve what we meant to protect. That's why cryopreservation uses gentle curves and special solutes that guide water into a glassy state without spikes, less a freeze than a lullaby in slow motion. Heat prefers to spread. From a star's bright heart to a bowl of soup on a wooden table, energy looks for room. Cold is simply the name we give to the quiet end of that journey, where motion is small and time feels patient. The mind can rest there a while, noticing how warmth leaves like a theater, crowd hats on, voices low, a polite shuffle toward the cool night. It helps to walk the scale, not with a ruler but with images that breathe. Picture a river of lava, fresh basalt rolling at roughly 1,200 degrees C, a heat that softens metal and ends the argument quickly for anything delicate. Step outward to the sun's photosphere, around 5,500 degrees C, where light peels off in sheets. Deeper in the core, about 15 million degrees, protons squeeze close enough to fuse, and daylight across Earth is the interest paid on those relentless unions. That's the loud end of the orchestra. The center softens as we drift toward familiar life. A midsummer afternoon settles near 30 degrees C. A quiet room holds around 20 degrees. Bodies idle in comfort at about 37 degrees. Busy, but not hurried. Water stiffens to ice at 0 degrees. Winter mornings wander below, and the poles remind the skin how clean and efficient cold can be. Around 70 degrees C, Antarctica can feel like a different planet, breath turning to glitter. Plunge further and nitrogen, ordinary as air, liquefies near 196 degrees C. Dipped into that clear, boiling cold, a flower will shatter like spun sugar beauty, dissolving into physics with a soft crack. Beyond our weather and our windows, space carries its own steady whisper. The universe still glows with the leftover light from its beginning, stretched by expansion into microwaves that cool everything they can touch. That background rests near 2.7 K, about 270 degrees C, so close to absolute zero that the numbers barely have room between them. Most of the cosmos, most of the time, is not blazing like a star. It is leaning toward this hush. Clouds of gas doze for ages, warmed only by faint starlight and the small frictions of their own slow movements, until gravity gathers them and the music of heat begins again. The body learns small crafts in such air. Blood vessels in fingers and toes tighten to keep the core steady. Muscles begin tiny, rhythmic shivers to burn fuel as heat. Breath leaves a ghost and returns cooler, and the mind, if it chooses, can ride those moods without alarm. Inhale, as if you're drawing a shawl across your shoulders. Exhale, as if you're lending a little warmth to the room. The skin sensors proteins that change shape near certain temperatures tell a story to the brain about comfort, caution, or pain. They aren't thermometers. They are scouts at the frontier, sending news in simple words: safe, steady, careful. Cold alters time's texture. Bread lasts longer in a winter pantry than on a summer counter. Fruit sleeps. Microbes slow their chewing of whatever they find. In lakes and seas, water does a kind trick. It becomes less dense as it freezes, so ice floats and makes a lid, letting life continue underneath in liquid shadow. Even in our homes, we place leftovers where motion is small and wake to meals that remember yesterday without complaint. There are limits worth honoring. An organ cannot be tossed into a chest of ice and hope to wake whole. Its cells hold shapes that must survive the crossing. Scientists slow the cooling, add cryoprotectants that coax water into a smooth, glass-like form, and then, when the time comes, warm carefully so that structures rehearse their old roles without splintering. The art is in the slope of the curve, the patience of the ramp. Too fast and cracks, too slow and damage of another kind. The story is always about motion and how gently we ask it to change. Even our feelings of wet cold and dry cold have physics tucked inside. Damp air and damp clothes steal heat with more eagerness. A breeze sweeps away the thin boundary layer of warm air snuggled against the skin, letting conduction and convection carry energy outward with renewed enthusiasm. Cover the wind, stay dry, and the body's small furnace works with dignity. Let moisture in, and the chill writes quicker lines. Some evenings it helps to measure less and notice more. A hand around a mug, the quiet fog from the rim, the way metal feels sharper than wood because it moves heat away from you more quickly. Materials differ in thermal conductivity. That's why a steel rail bites, while a wool blanket forgives, even if both share the same air. The world is a set of bridges for energy to cross, some long and slow, some short and swift. All of this lives beside a gentler truth. Cold is not a villain sneaking under the door. It is balance, patiently expressed. Heat flows toward where it is wanted less. Entropy, the habit of energy, to spread and states to mix, gives the arrow its direction. The cosmos cools as it expands, and in that cooling, structure appears and rests. Crystals choosing their lattices, snowflakes writing brief poems of symmetry, ice on a quiet pond, catching the moon with steadier hands than water could ever manage. If the night feels brisk against your window, let it be a teacher without scolding. Warmth leaves you not because the dark is cruel, but because the exchange keeps everything honest. Wrap your feet, hold the cup, breathe like tides under a thin crescent. Somewhere above the roofline, the universe hums at a temperature set billions of years ago, a soft note around 2.7 K that brushes every atom with the faintest hand. Here, close to your own pulse, the lesson is the same. Where motion slows, peace can widen. Where energy rests, attention can too. In that unhurried space, even the sharpest cold becomes a companion, quiet, clarifying, strangely kind. And if that gentle hum is the universe's natural floor, there is a deeper quiet our equations imagine but nature rarely grants. There is a number that sits at the far end of the scale, like a horizon at dusk. Absolute zero. 0 Kelvin. 273.15 degrees Celsius, 459.67 degrees Fahrenheit. It marks the limit where thermal motion would be as small as nature allows, where atoms would stop their busy shuffling and the world would seem to hold its breath. Not a new kind of cold, but the total absence of heat motion pared down to almost nothing, stillness made measurable. It's a finish line we can see with perfect clarity yet never quite reach, the way a mirage offers water and gives you distance instead. Nature has drawn a boundary there with a firm, patient hand. The closer a system creeps toward absolute zero, the harder the next step becomes. The third law of thermodynamics says the cost of removing the last scraps of disorder rises without mercy. Each fraction of a degree demands more finesse than the one before it, like trying to pluck the final notes of a lullaby from a string that barely vibrates. Even if you were impossibly careful, a kind of irreducible trembling would remain zero-point energy, the tiny motion left by quantum uncertainty, the rule that says you can never know both position and momentum with perfect confidence. There is always a whisper in the silence. And yet, we've learned to walk remarkably close. In carefully dimmed laboratories, atoms have been coaxed to within billionths of a Kelvin above that boundary. Light does the gentlest pushing. Laser beams tuned just so meet atoms moving toward them and steal a sliver of speed with each encounter. This is Doppler cooling starlight in reverse, not warming a face, but slowing a particle. Magnetic fields and counteracting laser beams weave a soft, invisible net called a magneto-optical trap, a place where atoms are held like dust in a sunbeam. After that, another kindness, evaporative cooling, where the liveliest atoms are allowed to escape while the rest settle into a deeper calm, like steam drifting away and leaving the tea a little cooler each breath. At these temperatures, matter shows us new manners. Cloudy swarms of atoms collapse into a single shared state, a Bose-Einstein condensate, many particles acting like one, their identities overlapping until the group behaves as a single wave. Superfluids slide without friction. Superconductors carry current without resistance. Patterns appear that make no sense at room temperature and seem inevitable in the cold. The world doesn't merely slow. It reorganizes into simpler sentences, grammar stripped down to clarity. Even so, absolute zero itself stays one step ahead. It isn't a destination for any real substance, only a direction that's a comfort in its way. If a system could be perfectly still, its entropy, the measure of spread and possibility, would fall to nothing, and the arrow of time would lose a little of its aim. The universe prefers a touch of rustle, a little randomness, a little room to breathe. The Kelvin scale keeps the bookkeeping honest. Begin at zero, where thermal energy is as small as it can be, and move upward as motion grows. No negatives in everyday matter, no shifting reference points tied to the moods of water. One glance tells you which gas is livelier, which crystal is calmer. A room might sit near 295 K, a winter field around 260 K, liquid nitrogen resting at about 77 K, and the cosmic background near 2.7 K, a tidy ladder from busy to quiet. Celsius feels homey, 0 degrees for ice, 100 degrees for boil, a kitchen logic that makes recipes and weather conversations easy. Fahrenheit carries its own domestic charm, fine-tuned to the comfort band of skin and seasons. Despite its eccentric birth in brine and body heat, it hugs the range where people live and decide whether to reach for a sweater. However, the numbers are dressed. The thing being measured is the same: how much motion hums inside. The range those numbers must cover is astonishing. There are temperatures where hydrogen nuclei are pressed close enough to fuse and send daylight across space. And there are reaches where only the faint afterglow of the Big Bang remains to warm the dust. Somewhere in the middle is the narrow alcove where you rest tonight, a human body content at roughly 310 K on the inside, and a room holding steady within a small hand's breadth of that mark. The universe spans millions of degrees, from its loudest to its quietest. The body occupies a sliver, so thin it might be a line, yet all of it follows the same rules. Think, for a soft moment, about a place colder than the background of space itself. Far in the southern sky, in the direction of Centaurus, lies a delicate artifact of a dying star called the Boomerang Nebula. Planetary nebulae are misnamed gifts. They have nothing to do with planets and everything to do with endings. A star near the end of its life exhales its outer layers, sometimes as a hush, sometimes as a gust, and the shed material blooms into shapes that catch starlight for a while before fading into the dark. In the Boomerang, that exhalation became a wind of breathtaking speed, hundreds of thousands of kilometers per hour, gas rushing outward into thin space like a sigh that never meets resistance. When a gas expands that quickly without outside heat, it cools. The same humble principle turns the nozzle of a compressed air can frosty and makes an air conditioner's coils cold. The faster the expansion, the deeper the chill. In the Boomerang, the flow is so swift and so thick that it builds its own shade, a cocoon that blocks the faint 2.7 K warmth of the cosmic microwave background. Inside that shield, the temperature can fall to about 1 K lower than the surrounding universe, a pocket where the whisper softens further still. Astronomers first noticed this oddity by what it failed to do. It didn't glow the way a warm cloud should in certain wavelengths. Sub-millimeter observations found a deficit of radiation, a silence where murmurs were expected. Later images sketched an hourglass form, twin lobes streaming from the central star like the wings of a ghostly moth. The Boomerang name came from the blur of ground-based views. With Hubble's sharper eyes, the shape looked more like a fine glass waste, with two cold veils billowing outward. Labels are less important than the physics. A star, having burned long, now sculpts a freezer out of its own breath. The elegance is temporary. As the gas keeps spreading, it will thin. Light from the wider sky will seep in. The shield will fail, and the temperature will drift back toward the cosmic baseline. For a little while, though, the nebula holds a singular quiet, colder than the night that surrounds it, made not by ice, but by emptiness and speed. Endings in space are often like that. Not always fireworks, sometimes the contented exhale after a long song. It's natural to wonder how such cold would feel. No air to breathe, no pressure to hold skin in place, no sound, only a near vacuum and a deep, patient hush. Were it possible to stand there whole, the sensation wouldn't be dramatic. Drama needs motion. It would be a kind of suspended waiting, energy drained of hurry. Not a peaceful meadow's quiet, but a museum's after-hours stillness, as if every molecule had stepped back from the glass. Objects under those conditions carry on their small chemistry differently. Molecules collide less, reactions pause, fragile structures keep their shape longer. That's why the cold in our own world is a tool and not just a season. We slow microbes and keep food, preserve vaccines on careful journeys, store seeds for futures we haven't met. In cryogenic tanks, cells nap in liquid nitrogen, time stretched by chill, until the next page is ready to be turned. The art lies in avoiding ice crystals that claw and crack. Special solutes encourage a glassy state rather than jagged frost, a smooth sleeping instead of a harsh freeze. The same habits that govern a kitchen freezer scale to the sky. Expansion steals heat, shade protects a calm, thin gas refuses to warm unless something feeds it energy. The Boomerang Nebula merely pushes these habits to their limits. A dying star, instead of lighting a last bright flare, cools a pocket of space to the coldest natural temperature we've measured. Not a roar, but a sigh. Not brightness, but restraint. Even there, even at 1K, the rules we use around a bucket of liquid nitrogen or a puff of compressed air still carry the story. Cold is behavior, not a character. It is energy, stepping back, movement, deciding to rest. The numbers remain simple companions in the background. Kelvin for clarity, climbing from 0 upward without fuss. Celsius for the rituals of water and weather. Fahrenheit for the ordinary conversations of comfort and coats. None of them change what the atoms are doing. They only translate the hum into units we can mark on a dial. A gas at 300 K holds 3 times the thermal energy per particle as one at 100 K. A room at 68 degrees F feels welcoming because skin and air are close enough in their negotiations that the body can idle without complaint. The scales are different lullabies, set to the same melody. It's quieting to realize that the coldest voids and the warmest hearts in stars obey the same phrases of physics. Heat spreads, entropy grows. Perfect stillness stays out of reach, leaving us a universe where motion can slow but never vanish, where there's always a trace of hum beneath the silence. The chase towards zero has shown us more than a number. It's revealed new states of matter, confirmed the stubborn kindness of the third law, and taught us to listen for patterns that only appear when the noise dies down. So the horizon remains where it is, and we keep walking toward it because the path is generous. A star exhales and writes a freezer into the dark. A beam of light meets an atom and asks it to slow. A scale begins at 0 and counts upward with good manners. Somewhere within that immense span of cold and heat sits a room, a blanket, a pair of steady lungs. The same rules hold at every rung. The same patience applies. And in that patience, the universe offers an odd consolation. Even the quietest places are not empty. They are full of order and possibility, waiting without hurry for whatever warmth will someday arrive. To see how far that patience reaches, you can step backward in time to the first moment when order found room to breathe and light learned how to travel. Before spirals unfurled and stars learned their steady shimmer, everything was close, so close it was more pressure than place. A hot, crowded broth of energy and particles. No night, no quiet corners, only brightness and bustle. Expansion drew a long breath, and with each moment, the heat thinned. About 380,000 years after that first beginning, hardly a heartbeat on cosmic time, the universe cooled enough for a small grace to happen. Electrons settled into orbits around protons. Neutral hydrogen formed. With the charge-tossing chaos eased, light no longer ricocheted like a pinball. Space turned transparent. For the first time, photons could leave home and keep going. Those photons never stopped. They're still moving past your shoulders even now, softened by time. Their once blazing color stretched into gentle microwaves by the universe's expansion. This is the cosmic microwave background, the oldest light we can see, a kind of afterglow from when everything was young and undefined. It's not something eyes can catch. It isn't flashy. It murmurs instead of sings, bathing every direction with the same quiet tone. Measured as temperature, it rests at about 2.725 Kelvin, roughly 270 degrees C, just a breath above absolute zero. Thin in energy, vast in reach, it sets a practical floor for the universe's cold. Wander far from stars and dust, and you still won't slip much below that. Not without some special shelter, like the rare deep freeze pockets inside a nebula's dense shade. Microwave here means wavelength, not kitchen warmth. That ancient glare began fierce and blue-white, but billions of years of stretching dragged it down the spectrum, cooling as space itself expanded. If expansion had never happened, that light would still arrive like hard ultraviolet or X-rays. Instead, it rocks a cradle song pitch, a background hum that never quite turns off. When Arnaud Penzias and Robert Wilson worked on a horn antenna in New Jersey in the early 1960 seconds, they couldn't get rid of a persistent hiss. They scrubbed the equipment, shooed pigeons, tidied what was left behind, and aimed the antenna all over the sky. The hiss stayed. It was not earthly noise. It was the universe, faint and even, a relic broadcast from its early days, sliding right into their receiver. Their careful annoyance turned into a Nobel Prize, and the hiss became a map-making project for generations. The first broad portrait came with Kobe in the 1990 seconds. It showed that the background isn't perfectly smooth. The temperature ripples by about 1 part in 100,000 tiny, but powerful enough to seed structure. Those slight swells and dips grew into galaxies and clusters, the hushed beginnings of everything, large and luminous. WMAP sharpened the picture. Planck refined it further. The sky in microwaves looks like silk, with a fine grain. Small blotches, warmer here, cooler there. In those patterns hide answers about age, geometry, and ingredients. Measure them well, and you learn that the universe is about 13.8 billion years old, mostly dark energy and dark matter by budget, slightly curved only in stories, but flat enough in measurements to carry on straight. Even the light's polarization carries clues, twists, and alignments that might someday reveal the imprint of inflation, that early sprint when space itself ballooned faster than any signal could chase it, perhaps leaving behind the faintest rumor of primordial gravitational waves. For all its significance, the background behaves like a considerate roommate. It's everywhere, but it doesn't intrude. Old televisions once caught a tiny slice of it as snow dance static. A small fraction of that fuzz was the universe's oldest whisper. Sit in a quiet room at night, and nothing in your body knows it's bathing in ancient light. And yet, everything is. The atoms in your bones learn their habits in a cosmos that has never been fully dark. Because the glow fills all directions, it acts like a cosmic thermometer, drift between galaxies, far from starlight, and the cold you feel is governed by the same number to 2.7K. You can hide only by building shade of your own dense gas, dust, a curtain thick enough to block the background's faint fingers. Otherwise, the light gets in, not as beams but as presence, equal from every side. The story in those photons is generous. Temperature tells you about the early clumping. Polarization angles hint at the way space stretched. Spectra, how brightness varies with frequency, match almost perfectly a black-body curve, the signature of a hot, thick origin that cooled evenly. The fit is so precise it calms the mind. This is not a coincidence. It's a fossil that stayed faithful during a very long voyage. Far from any warm sun, between the scattered islands of galaxies, space keeps a different kind of quiet. The temperature there hovers near that same 3K mark. The surprise is not how cold it is, it's how empty. In a cubic centimeter of interstellar space, you might find a single lonely atom. In the air beside your cheek, there are roughly 25 sextillion molecules in that same volume. Emptiness changes what cold means. There is hardly anything to carry heat away, hardly anything to hold it in. The background sets the mood, but the room is almost bare. And yet the emptiness is not barren. In the quietest pockets, where dust builds up and starlight cannot pry as fiercely, clouds of gas grow dense and cold enough for chemistry to slow into cooperation. These are molecular clouds, shadowed regions holding mostly molecular hydrogen, a little helium, and traces of molecules with personalities, carbon monoxide, to trace the gas, ammonia, whispering of denser clumps, methanol, and formaldehyde, rehearsing more elaborate steps, even precursors of amino acids, tucked like small secrets on dust grains. Temperatures here can fall to around 10 Kelvin. Dust coats itself in ice's water, carbon monoxide, carbon dioxide, thin mantles that help shield the heart of the cloud from ultraviolet mischief. Without dust, harsh light would tear apart fragile bonds before they had a chance to settle. With dust, the cloud learns patience. Cold is not just backdrop, it's a tool. When motion slows, collisions become gentle enough for atoms to stick instead of shatter. Bonds form, molecules gather. Over long spans, millions of years, a patch inside the cloud can grow denser than its surroundings. Gravity likes that. It tugs a little harder. The region shrinks. Heat begins to bloom from compression, and the center brightens. What was once a chilled, obscure lump becomes a protostar wrapped in a dusty shawl. The paradox is beautiful. Fire begins in a place that learned how to be still first. These clouds don't show themselves in ordinary light. They block it, seeding dark lanes across the Milky Way, smudges where star fields go missing. Radio telescopes listen for their molecules instead, tuning to precise frequencies where each species hums. Infrared instruments catch the faint warmth of dust and the glow from newborn stars still swaddled in their cocoons. In Orion, not far from the familiar belt, an enormous complex of gas and dust sprawls across hundreds of light years. There, pillars and knots hide stellar embryos. Outflows carve cavities. Shock fronts write ripples across the cold. The nursery is busy, though you'd never guess it from a photograph that shows only darkness. The activity hides inside, and the inside is cold. Nothing in these regions happens quickly. A human life fits between ticks of their clock. Chemistry inches along. Grains grow layers. Photons stray and are swallowed. But slow is not the same as empty. A snowflake writes a whole story in a moment of falling. A molecular cloud writes one in patient strokes over ages. The same rules you can trust in the kitchen cooling changes texture, shade preserves, slow processes reveal structure, are at work on scales that make distances into poetry. The background glow keeps score while all this unfolds. It isn't a tyrant. It's the baseline, the quiet against which the music stands out. The universe never erased its first light. It stretched it, softened it, and let it linger. That soft floor of temperature means there's always a touch of warmth everywhere, enough to keep true stillness out of reach. In that almost zero, complexity finds room to form. If the cosmos had frozen completely, there would be no rehearsals, no delicate bonds. A whisper of heat is the price of story. Back in the days when instruments were less refined, some of this story arrived as inconvenience, a hiss in an antenna, snow on a television. With care, inconvenience became signal. With better maps, signal became portrait. The tiny blotches on the CMB sky are not decorations, they're blueprints. Their sizes and contrasts tell you how matter and light danced in the first moments, how fast the universe expanded, how gravity and pressure traded lines in the score. Even the way the blotches align across different scales hints at the physics of that earliest fraction of a second, when quantum jitters were stretched to macroscopic ripples. Somewhere in those patterns may hide the faint corkscrew signature of gravitational waves from that first rush, a curvature ripple frozen into light. It's hard to find. Noise pretends. Dust masquerades. But the search itself is a kind of lullaby. Careful, repeated, attentive. Out in the spaces between, where the background rules and matter is few and far between, stray atoms still meet. Sometimes a cosmic ray barges through and kicks an electron loose. Sometimes a distant star's photon finds a dust grain and warms it by the smallest degree. Even at 3K, small things happen. Hydrogen spins flip, emitting a photon at 21 centimeters. Astronomers listen for that line to trace vast streams of gas across millions of light years. The line's whisper builds maps of structure we cannot see otherwise, maps that show filaments and voids, a web-like skeleton on which galaxies hang like beads. Step back, and the pattern is soothing. A hot universe cooled and became transparent. Its first light still fills the room. Slight wrinkles in that glow matured into galaxies. Between them, the temperature settled near a floor set by memory. In the darkest, densest corners, dust dimmed the light enough to let chemistry proceed. Cold gathered matter. Gravity found a grip. New stars swelled from that gathered quiet, and with them came planets, ices, oceans, and the patient permutations that make life possible. Warmth, it turns out, is often something cold prepared the way for. If you listen to the night beyond your window, none of this is noisy. The background doesn't thunder. Molecular clouds don't clap. Even starbirth keeps its voice down until the first photons slip through cracks in the dust. The universe does a surprising amount of work in whispers. It keeps a steady temperature in the places where there is nothing else to do, and in the places where there is everything to do, it lets cold make room for order. The numbers are simple: a handful of kelvins in the void, about 10 in the clouds, a few 100 billion in the beginning, and the meanings are gentle. Light moves, bonds form, heat spreads, structure rises. The silence is busy. Somewhere tonight an antenna is pointed at a patch of sky that looks empty. In that Empty, the oldest light continues its long walk, and behind it, inside a shadowed cloud, a slow collapse tightens and warms. On a time scale too long to worry, a star will arrive. On a time scale you can feel with your hand, the room will hold its 290-something Kelvin with comfort. On a time scale between those two, the mind can rest in the knowledge that cold is not the enemy of life. It is its patient accomplice, keeping the din outside until the music is ready, and the doorway it guards is a dark cloud where dust and dimness give chemistry time. Fragile chemistry survives in hard country by finding shade. The same dust that keeps a cloud cold also grants molecules privacy, sipping up harsh ultraviolet light and softening cosmic rays so that bonds can form without being snapped apart. In those deeper, denser pockets, the temperature falls lower still. Even carbon monoxide settles out of the gas and plates itself onto dust grains as frost. Those icy skins become small workbenches. A stray ultraviolet photon taps the surface, nudging atoms into new partnerships. Hydrogen adds itself here, oxygen migrates there, radicals meet and quiet down. Laboratory jars chilled and irradiated to mimic these clouds have teased out simple amino acids from such ices, glycine-like whispers grown on the backs of grains. The galaxy's coldest corners behave like slow kitchens, rehearsing recipes life will later borrow. Between galaxies, the temperature is closer to the background floor, and the emptiness more complete. Out in those broad voids, there isn't enough matter to gather a cloud, let alone a chemistry set. The thermometer stalls near 2.7 K, and there is little to do but drift. Even this quiet has purpose. Contrast makes pattern. The cold gives warmth its edge. Silence makes the music legible. Darkness shows you where the stars are. Without such a backdrop, a blaze is only brightness. With it, structure appears and meaning takes hold. In the chill, hydrogen waits. Gravity learns its route. Time does the slow stitching that turns scattered atoms into futures. Some of the universe's coldest theaters live not in space, but under fluorescent lights and careful hands. Near absolute zero is not a place you can order from a catalog. It's a choreography. Atoms are persuaded, not forced, and the tools are built to tell them small, patient stories. A laser, tuned to a frequency an atom loves, nudges it backward when they meet head-on. Do this from many directions, and the atom loses speed in gentle bites. This is laser cooling, the Doppler shift turned into a break. Magnetic fields add a cup of steadiness, shaping a bowl that holds the slowed atoms in a soft focus called a magneto-optical trap. Then comes a familiar trick with a new precision: evaporative cooling. The liveliest atoms are allowed to escape. The rest share less energy, and the ensemble sinks colder. In steps, the cloud moves from microkelvin to nanokelvin, from thermal blur towards something that feels more like a thought than a gas. When the temperature falls far enough, individuality blurs. A crowd of bosonic atoms, rubidium is a favorite, slides into the same quantum state, overlapping until many become one. This is a Bose-Einstein condensate, imagined by Satyendra Nath Bose and Albert Einstein a century ago and first coaxed into being in 1995. It does not act like familiar matter. Ripples travel through it like sound across a calm lake. It can tunnel through barriers, When set spinning, it forms tiny, neat vortices like a miniature galaxy pinned in glass. You don't see it with your eyes. You infer it from the way it answers questions. How a probe of light passes. How the cloud expands when the trap is turned off. How motion refuses to look random. The first clear, steady condensate made from rubidium atoms in Boulder by Eric Cornell and Carl Wieman earned a Nobel in 2001. Since then came sodium clouds, potassium clouds, mixtures with two interleaved quantum fluids, and precise dances that imprint patterns on matter waves the way interference fringes stripe light. Laboratories at MIT, Stanford, Jilla, and sister centers across Europe and Asia have tuned their rooms into sanctuaries where the cold is not a season but a technique. Some have brushed temperatures within a billionth of a Kelvin of the floor, a place where temperature feels more like bookkeeping than sensation. Orbit helps, too. Aboard the International Space Station, NASA's Cold Atom Lab gives atoms time to hover. Microgravity loosens the grip of the trap. Atoms don't sag. Clouds can be held and studied longer. The freezer in orbit isn't for ice cream. It is for watching quantum rules step forward when heat steps back. Cold reveals traits that warmth hides. Superconductors, metals, and ceramics that carry current with no resistance wake at low temperatures, and their neat, lossless loops make MRI magnets steady and particle accelerators disciplined. Qubits in some quantum computers hold their states longer when the thermal jitter is hushed. A drop in temperature can be a magnifying glass, pulling fine structure into focus. The world behaves ordinarily when busy. It becomes articulate when calm. Of course, most of us meet cryogenics by way of practical magic. Liquid nitrogen, boiling briskly at 196 degrees C, makes rubber shatter and herbs turn crisp. It keeps seeds, blood, and delicate reagents sound, while months pass outside the tank. The plume looks theatrical, but the physics is tidy. A liquid becoming gas, carrying heat away, protecting order by slowing motion. Antarctica's wildest recorded cold, near 93 degrees C, is no contender beside this. Nature on Earth does not furnish temperatures for superconducting rings or nanokelvin clouds. To measure such stillness, you don't use a mercury column. You listen to lines in a spectrum. Watch how a cloud expands when released. Read the distribution of velocities, the way a musician reads a score. What matters isn't the record, it's the clarity. As motion dies down, the script of quantum mechanics stops being a murmur behind the scenery and becomes the play itself. Randomness gives way to pattern. The stage lights dim, and you notice the choreography that was always there. Heat had kept the cast improvising. Cold asks them to move as one. In that hush, the everyday rules loosen. In a solid, at room temperature, atoms vibrate like nerves in a fingertip, jostling but bound. As the thermostat sinks toward a few Kelvin, the jostling falls away, and what's left is the logic of the lattice and the restlessness that quantum mechanics never lets you quite extinguish. Zero-point motion is the last tremor, the uncertainty principle's signature, a promise that perfect stillness is off-limits, not by engineering but by nature's mathematics. Liquids take on stranger graces. Helium, which refuses to freeze at ordinary pressures, even at temperatures near absolute zero, crosses a quiet threshold around 2.17 K and becomes a superfluid. Viscosity goes missing. Pour it through a thin capillary, and it slides as if the walls forgot to touch it. Set it in a shallow dish, and it creeps up and over the edge in a thin film, an impossible party trick that refuses to feel friction. Spin it, and it cannot swirl the way water does. Instead, it arranges its rotation into a regiment of microscopic whirlpools with quantized circulation vortices, spaced and counted like stitches. The liquid is not showing off. It is obeying a simpler law that heat usually drowns out. Cold also writes bridges between worlds that look separate when warm. In metals, electrons couple into pairs that move together instead of colliding, and resistance collapses to zero. In certain insulators cooled and doped just so, current flows along the edges without loss, while the interior stays quiet, a topological promise enforced by geometry more than material details. In gases thinned and calmed to condensation, matter behaves like a light field you can sculpt. With the right pulses, you can split a cloud and let the halves interfere when reunited, building interferometers from atoms the way earlier generations built them from photons. Measurements borrow coherence from the cold and repay it in precision gravimeters that can read a basement's density change as water tables shift, clocks that lose a second over the age of the universe if treated kindly enough. All of this returns, gently, to dust and clouds and the long night between stars. The chemistry on icy grains is a cousin to the tricks in a lab. Low temperatures suppress the noisy reactions and favor pathways that warmth would erase. Ultraviolet light in space serves as the nudge lasers provide in glass and steel rooms. Grains play the role of traps, holding atoms close long enough for something improbable to become inevitable. When enough structure gathers, gravity picks up the thread and heat re-enters the story, not as enemy, but as consequence. Fire is born from a careful cold. The coldest voids are not dead. They are quiet studios. The emptiness between galaxies is not neglect. It is the breathing space that lets patterns stand out. The labs that chase nanokelvin temperatures are not hunting trophies. They are easing the world into a register where its deeper grammar speaks in complete sentences. You can call it fragility, because such states are easily disturbed, or you can call it resilience, because the rules that make them possible apply everywhere and always. Either way, the message is kind. When motion slows, the hidden coherences appear. When noise fades, signal is not manufactured, it is revealed. If you could lean close to a condensate, you would not hear it. If you could trail a finger through a bath of superfluid helium, you would feel less than you expect. The liquid refuses to argue. If you could shrink down and stand on a dust grain wrapped in ice, you would watch patient reactions write scaffolds for later years. Slow is not empty. Cold is not lack. They are conditions under which the world tells the truth more clearly. And when scientists read temperature that low by watching atoms faint change in color, by timing how a cloud breathes when released, by counting vortices too small for any fingertip to feel, they are not merely tallying digits. They are listening for the rhythm beneath the noise, measuring how close matter can come to an ideal that mathematics, sketches, and nature approaches, but never touches. The universe keeps that last step for itself. In the space between here and there, it leaves us room to learn. Lower the lights almost to nothing, and helium does something that feels like a magic trick, performed with perfect manners. At a little above 2 Kelvin, it crosses a quiet threshold and becomes a superfluid. Not a cold or ordinary liquid, but a substance with a different kind of memory, none at all. Set it swirling in a smooth container, and it will keep its circle without tiring. A motion that doesn't fade because there is no internal friction to rub away its energy. Not less resistance, not barely any, but zero in the way a still pond has zero ripples. the liquid does not remember how to slow. In that state, it behaves with a strangeness that's easy to describe and hard to believe. A thin film crawls up the walls of a beaker and spills over the lip, a climbing that isn't driven by heat or pressure, but by the coherence of a single quantum wave spread through the whole liquid. The atoms act together, not as a crowd of individuals, but as one extended self, a bowl filled with a single, shared heartbeat. Helium is nearly alone in this stubbornness. At normal pressure, it refuses to freeze even if you beg it with every degree you have. Only by squeezing it with enormous force can you nudge it into a solid. That makes it a kind of winter garden for physics, a place where quantum rules that are usually hidden in the noise of warmth step forward and bow. Scientists have watched superfluid helium slip through impossibly narrow cracks without losing a step, have spun it and seen its rotation quantize into neat, microscopic whirlpools spaced like careful stitching. Tilt a container, and the liquid seems to ignore the urge to slosh the way water does. It prefers to move as a whole, with a poise you'd more expect from light than from matter. The surprise is not that the universe can do this. The surprise is that it refuses to do it unless you make it quiet enough to listen. At almost the same temperatures, electrons in certain solids learn a similar grace. Ordinarily, an electric current is a slightly clumsy parade. Electrons jostle with the lattice of atoms, turning some of their energy into heat. The reason wires warm and toasters glow. Cool the right material below a critical temperature and a different script begins. Electrons couple into pairs, Cooper pairs, tiny partners bound not by romance, but by a subtle attraction mediated by the lattice itself. Paired like this, they slip through the material without scattering. Resistance collapses to zero, and the current becomes a river that never rubs against its banks. In such a state, magnets levitate serenely above a cool disk, pinned by invisible lines of magnetic flux that the superconductor corrals and refuses to share. Power could, in principle, travel without loss. MRI machines lean on this steadiness to hold fierce magnetic fields steady without burning extravagant amounts of energy. Particle accelerators draw clean arcs with help from superconducting coils. Quantum computers ask for the same hush, so that qubits can keep their delicate superpositions intact long enough to be useful. The materials that do this best at accessible temperatures are complex ceramics and alloys cooled with liquid nitrogen or helium, and researchers keep hunting for compounds that can shrug off resistance while warmer, inching the convenience closer to the ordinary world. Hints appear, excitement flares, reality corrects, and the work goes on, careful, patient, listening for a material that will keep its promise at kinder temperatures. Time itself feels different in this quiet, not the science fiction kind with doors through yesterday, but the way quantum states evolve when thermal noise fades. At room temperature, random vibrations shake apart the subtle links between particles, and coherence those fragile, extended states, where possibilities are superposed and phases line up, dies quickly. Lower the temperature, and the shaking eases. Quantum interference survives longer. Particles are more willing to tunnel through barriers that would stop them when the world is rowdier. A superposition can hold its breath. The fine print of physics becomes legible because the page is no longer smeared by heat. Cold becomes a lens. The rules do not change. They simply stop being shouted over. Atoms that used to jostle now sway together. Electrons that used to argue find partners and walk in step. Fluids forget friction. Currents forget loss. Order emerges not as a contradiction to nature, but as its quieter habit when distractions are removed. The elegance can look like a trick, but it is only a stripped-down sentence in a language that was there all along. There's a tender symmetry in this. At high temperatures, matter is lively, improvisational, hard to corral. Lower the temperature, and improvisation gives way to harmony. Lattices lock into cleaner shapes, spins align, waves add instead of canceling. The universe seems to prefer minimalism when given the chance. The fewer bits of energy bouncing around, the more cooperative the cast becomes. It feels counterintuitive that taking energy away makes the world more capable, but it's simply a different kind of capability, one that prizes coherence over hustle. Helium's superfluid grace has cousins in other systems. Cold gases of alkali atoms, condensed into a single quantum state, will interfere with themselves like light, matter waves, producing fringes that can be read like handwriting. Ultrathin films host electrical states along their edges that carry current without loss, a geometry-protected neatness that persists when the interior stays quiet. Even in tiny mechanical resonators, microscopic beams and membranes, cooling brings the motion close to its quantum ground state, where a single phonon, a single packet of vibration, can be counted and coaxed. The music softens and individual notes can be heard. The refusal of absolute zero to be reached is part discipline, part mercy. The third law of thermodynamics sits there with calm authority and says the entropy of a perfect crystal would fall to a constant as the temperature approaches zero, and that getting all the way there cannot be done in any finite number of steps. Each cooling technique works, then works harder, then works only a little, the returns diminishing, as though the target were walking backward at exactly your speed. The closer you come, the less heat there is to remove, and yet the task of removing it becomes more delicate and more demanding, like trying to still the last shimmer on a pond without making a single ripple. Quantum mechanics adds a boundary of its own. If atoms truly stopped, you would know where they were and how fast they were going here, and not going at all with a precision the uncertainty principle forbids. Zero-point motion remains, a whisper of restlessness in every lattice and trap. The best refrigerator you could ever build still has to move heat somewhere else, and when the somewhere else is almost as cold as your goal, the flow slows to a crawl. Blowing on soup with warm breath does not cool it. Trading heat with a refrigerant at the same temperature does not help. Evaporative cooling, letting the most energetic particles leave and taking energy with them, does wonders early, then limps as fewer hotheads are left to depart. Adiabatic demagnetization aligns little magnetic moments in a field, quiets their disorder, and then pulls the field away while the system is insulated so the moments stay calm and the temperature drops. It is beautiful and limited, a staircase that becomes a ramp and then a slope and then a floor. This is not failure. It is a shape written into the world so that motion can slow without disappearing, so that order can emerge without becoming brittle perfection. The last tiny jitter protects the rules that give us everything else. The unreachable limit becomes fruitful precisely because it stays unreachable. In chasing it, we discover superfluids, superconductors, long-lived coherence, clocks that keep time with astonishing grace, sensors that can feel the pull of a passing cloud or the quiver of a distant wave. Spend a few breaths with the images. A ring of superconductor holding a magnet in midair, steady as if the Earth had grown a new kind of shelf. A film of helium creeping up glass, a silver thread that won't let gravity have the final word. a tangle of quantized vortices in a rotating superfluid, arranged like a star chart in miniature. A cloud of atoms released from its trap and swelling as a single wave, not 1,000 particles. A qubit sheltered in a metal can colder than deep space, humming to itself in superposition, while the world outside thunders along at room temperature. These are not circus tricks. They are glimpses of what matter becomes when the noise turns down and the grammar of the universe speaks plainly. The way time moves through such systems is kinder to decoherence, the loss of quantum order as a system bumps into everything around it, slows when there is less around to bump into and less energy to trade. This is why quantum computers wear winter coats of dilution refrigerators, nested shells that step the temperature down and down until the buzz fades and the qubits can carry their intertwined stories without dropping them. It is why gravitational wave detectors sit in cryogenic calm, letting mirrors hang so still that a ripple from two black holes a billion light years away can brush them and be felt. Cold is not a luxury in these rooms. It is the operating language. There are still places where the map is drawn in pencil. Materials that flirt with superconductivity at higher temperatures then withdraw. Phases that appear only in thin films or under unearthly pressures. Odd oscillations that ask for new theories to explain them. Each time the field settles, some new wrinkle appears at a lower temperature, a finer scale, a cleaner sample. The deep freeze is not a finish. It is a frontier that keeps stepping back, leaving behind better instruments and clearer questions. All along, a simple refrain returns. Reduce the heat, and you reduce the random. What remains are the ties, the pairing, the coherence, the long-range order that heat had been smudging. It is tempting to call this purity, but it isn't quite that. The zero-point hum is still there, useful and necessary. The world never becomes a statue, just a slower dance where you can finally see the shape of the steps. If the idea of cold still feels like emptiness, notice how full the story becomes when temperatures fall. Liquids flow without losing themselves. Electrons take hands and move like a choir. Waves and matter draw patterns across labs and through orbiting experiments where microgravity gives the cold more time to work. The closer we get to the bottom of the scale, the more the universe reveals that it is not chaotic by nature. It is organized, but its organization is subtle and easily drowned out. Lower the volume and the melody emerges. Absolute zero remains beyond the gate, a horizon that keeps its distance no matter how far you walk. That is as it should be. The last flicker of motion carries laws we are not meant to turn off. We cool and cool again, and in doing so, we learn how friction disappears, how resistance collapses, how order assembles, how time can be shepherded into longer strands of coherence. Near the bottom, the universe gives its most elegant performance, not in thunder, but in poise. The stage is almost silent. The actors move as one, and from the front row, a quiet room, a steady breath, a mind drifting with the story, you can see the choreography clearly, as if it had been waiting all along for the house to go still. Scientists have tiptoed astonishingly close to the bottom of the scale. In quiet rooms threaded with laser light and magnetic fields, clouds of atoms have been cooled to within billionths of a Kelvin of the limit. At that stillness, motion shrinks to a murmur. Whole ensembles stop behaving like crowded markets and begin to move like choirs, many voices folding into one note. That's where Bose-Einstein condensates appear, matter settling into a single quantum wave that you can't watch with eyes, only infer from the way it expands when released, the way it ripples when tapped, the way interference patterns blossom like frost on glass. It isn't zero, but it is close enough for the fine print of physics to become legible. This closeness matters because heat is a chatterbox. At everyday temperatures, thermal noise smears the delicate signatures of the quantum world. Collisions tumble the careful alignments. Tiny effects drown in the crowd, lower the volume, and subtleties emerge. Interactions that are normally hidden pairing, coherence, tunneling, step to the front of the stage. Forces that seem simple at room temperature reveal extra layers of intention. Materials confess new talents when the jostling calms. From that calm come tools. Superconductivity current, flowing without loss, doesn't just make for clever science demonstrations. It anchors MRI magnets, sculpts the tracks of particle accelerators, and offers designs for power lines that wouldn't waste energy as heat. Qubits for quantum computers, fragile little storytellers, keep their tales intact longer when the temperature falls and the world stops poking them. Even the way we make new materials depends on what the cold reveals, how electrons arrange themselves, how spins line up, how lattices breathe. Each step closer to absolute zero sharpens the instruments with which we listen, letting us measure tiny shifts that hotter systems blur into silence. Still, the boundary remains a boundary. Absolute zero is like the speed of light. You can approach it, but you cannot arrive. Every decimal we add to our cooling achievements leaves a last tremor, untouched zero-point motion, a whisper set by uncertainty itself. There is something gentle in that refusal. The universe doesn't run on absolutes, only on limits that keep the game honest. Even in the quietest corners, a little restlessness remains, a reminder that motion and imperfection are not mistakes, but part of the design. So when someone speaks of nanokelvin gases, they're not just juggling impressive numbers. They're pressing an ear against the wall that separates what we know from what we're learning, listening for vibrations so faint they barely count as motion. Perfect silence never arrives, and that's all right. The not quite silence contains more information than any shout. Far from any fireplace of a star, deep space holds a different lesson about cold. It is not winter in a city cold. It is a slow, implacable, 250 degrees C kind of cold, the kind that comes from having almost nothing to hold onto warmth. There's no air to carry heat away, no wind to sting, no blanket of atmosphere to tuck energy in. Temperature. There is a conversation between an object and the emptiness around it, carried by light alone. Put something in that vacuum, and it doesn't freeze instantly. It cools by radiating its heat away, photon by patient photon, like breath fading on a window that never fogs. Spacecraft survive by turning that slow conversation to their favor. Insulation is the first kindness. Those crinkly gold and silver blankets, multi-layer insulation, aren't decoration. They're a stack of thin mirrors that reflect thermal radiation and trap still pockets of vacuum between them. A sleeping bag made of glints. Inside, electronics make their own small weather. Computers, batteries, and sensors shed a trickle of heat just by doing their jobs. Heat pipes and radiators, quiet couriers, carry that warmth where it is needed, or spill it to the dark when there is too much. It's like tucking a heating pad under exactly the right corner of a quilt while letting the rest breathe. Far from the sun, even that isn't enough. Sunlight thins with distance. Solar panels become stingy. The chill insists. For voyages where day never grows strong, a steadier hearth is needed. That's what radioisotope thermoelectric generators provide: a nuclear ember that glows for decades. Plutonium-238 decays and gives off heat. Thermocouples turn that heat into electricity with no moving parts to fail. The warmth keeps instruments within their comfort, and the power keeps them speaking across the years. The Voyager twins carry such hearts. Launched long before many of today's listeners were born, they are still whispering from beyond the planets. Their voltage is lower now but steady, their warmth carefully budgeted so the important parts don't grow numb. Even closer in, the dark can be demanding. Cassini, roaming Saturn's winter of light, used an RTG so that rings and moons could be visited without shivering. Other missions choose a colder path on purpose. The James Webb Space Telescope needed the night to do its work because it watches in infrared, where heat looks like light. Any warmth from itself would wash out the faint glow of distant galaxies and dusty nurseries. So it lives behind a 5-layer sunshield the size of a tennis court, angled always so that sun, earth, and moon stay on one side of the curtain. In that shadow, the observatory sinks to around 40K. One instrument dips even lower, down near 7K, with the help of a cryocooler, a little refrigerator humming, a lullaby, so the detector's own warmth won't confuse the ancient light it's meant to see. The cold asks for careful choices in materials. Greases that serve us well on the ground turn stiff statues in vacuum. Instead, mechanisms turn on dry lubricants, graphite, molybdenum disulfide, carefully designed coatings that slide without freezing. Metals shrink as they cool, so structures are built to contract without warping. Cables are made supple enough not to crack when night bites. Engineers test all of this not with hope, but with chambers that pull the air away, bathe the craft in heat and cold, and swing it through shadows until the design proves it can handle silence. Sometimes, lessons come the hard way. Systems drift warmer or cooler than expected. Regulators misbehave. A telescope hiccups. The fixes arrive, and the mission carries on. Space scolds, but it also rewards the correction with long, steady days of data. The same vacuum that chills also preserves. Without air, there is no rust, no storm, no fog of moisture to creep into cracks. A careful machine can last decades if its heart stays warm enough and its joints stay willing. The golden records on the Voyager spacecraft may wander for millions of years, their grooves unhurried by weather, their song protected by the very emptiness that makes everything else so cold. Cold, then, is both opponent and ally. It threatens to make a hinge brittle, but it holds an image steady for years. It tries to hush a receiver, but it keeps the background clean, so whispers stand out. The deepest dark can either starve a probe or let it work with a clarity that air would never allow. Survival becomes a matter of balance. Reflect what you don't want, keep what you do, and always know where the heat will go when the shadows turn. Think of a spacecraft not just as a traveler, but as a small hearth. Inside is a managed warmness, measured in watts and watched like a pulse. Outside is a sea that asks nothing and gives nothing unless asked with care. The contrast is part of the beauty, a gentle glow wrapped in foil, threading a path through a place that never stops trying to extinguish it, and failing because the design knows how to trade heat like a craftsman. All of this care has a way of circling back to us. The same cryogenics that keep telescopes quiet allow superconducting coils to hold fields steady in hospitals. The same philosophy that guides a sun shield block the noise. Let the signal through shapes the way we build instruments for fragile measurements on Earth. The universe teaches by extremes, and the lessons come home gentler. The mind can drift here to a softer question. If machines can be cradled through long winters of space, could people be, too? The thought carries a familiar glow from stories, crossing vast distances while the body sleeps, memories paused, and futures held, like a book with a finger between its pages. The physics of warmth and stillness sets the boundaries. Biology asks its own. For the moment, it is an idea with a coat on, waiting at the door. The night is very wide, and the temperature is honest. And somewhere, a quiet room hums at a steady set point, while an antenna listens for a signal that left home before we learned the word cold. Stories make it look easy. A silver pod, a soft hiss, a long sleep that keeps a traveler fresh through the dark. No hunger, no clocks, no long conversations with a patient ship. Then a quiet awakening decades later, wrinkleless, rested, ready. Down here, bodies are less obliging. The dream has a real name, suspended animation, and pieces of it already live in nature. Wood frogs in northern forests let winter take them, heart stalled, water in their tissues partly replaced by sugars that act like antifreeze. Spring comes, warmth returns, and the frogs start again. Turtles, insects, even certain fish ride out cold in similar pauses. Life learned to dim itself without going out. Human cells are less forgiving. They carry a great deal of water, and water loves to crystallize. Ice grows sharp and literal, punching through membranes, tearing delicate architecture. What looks like a gentle sleep becomes a shattered sculpture. To keep structures safe, medicine uses cryopreservation, cool tissues, very low around the boiling point of liquid nitrogen, 196 degrees C, while flooding them with cryoprotectants, chemicals that slip into cells and discourage ice. Done well, water bypasses crystals and slides into a glassy state instead, a process called vitrification. Sperm, eggs, embryos survive this transition routinely. Thin sheets of skin, corneas, small slices of tissue can be saved, shipped, and woken. The smaller and simpler the structure, the kinder the outcome. Whole organs make the problem larger in every direction. A heart has thickness and twists of vessels. A liver carries a forest of ducts. A brain is a map made of threads finer than hair. Cooling must be even. Warming must be even. Cryoprotectant must reach everywhere without poisoning the very cells it protects. Freeze too slowly, and ice creeps in during the descent. Warm too slowly, and ice forms on the way back up. Warm too quickly, and stresses cracked tissue like glass, plunged from cold into heat. Researchers are learning tricks, nanoparticles that turn radio waves into gentle, uniform warmth, perfusion schedules that balance speed and safety, cryoprotectant cocktails that lower toxicity while keeping ice at bay, but a whole, complex body remains beyond reach. That has not stopped people from asking for a place in tomorrow. Cryonics organizations offer full body preservation or, for those who trust the brain's pattern most, neuropreservation. After legal death, cooling begins. Vessels are filled with cryoprotectant. Temperature sinks toward liquid nitrogen. Quiet. The hope is patient and explicit that future tools will repair damage and restore a person who was carefully kept from further decay. There is honesty at the center of this hope. No human, and no large mammal has been cryopreserved, vitrified, stored for years, and brought back to life. It is not a medical service. It is a time capsule with a wish inside. Shorter pauses draw closer to practice. In emergency rooms and surgical suites, deep hypothermia slows the body's need for oxygen so that teams can buy minutes, sometimes an hour, when a heart has been stopped to repair what cannot be fixed while blood is moving. In trauma experiments, rapid cooling has stretched the window for intervention. This is not hibernation and not decades. It is a carefully measured hush, a pause button for crises when time must be made out of temperature. Turning that hush into a voyage asks for a chain of small miracles that add up to a large one. A traveler would need to be cooled without ice, kept stable for years without power flickers or chemistry drifting, and rewarmed without fracture or confusion. Cognition would have to rethread itself. Memories would have to wake where they left off. Even if the engineering were solved, the questions would keep their gravity. If a person leaves in one century and arrives in another, who are they to the law? Who is responsible for their care? What debts, what rights, what promises carry across an interval the world did not share? It is one thing to trust a ship. It is another to trust a future. The mind, too, would need gentleness. Memory is not a file, but a living weave. Skip enough time, and the world you return to may not recognize your stories. Navigation would mean grief and wonder in equal measures. Still, the idea persists because the distances do. The nearest stars are too far for a straightforward trip inside an ordinary lifetime. Without shortcuts through space, the only trick left is a shortcut through experience. Make the journey pass unnoticed to the traveler and let the ship keep watch. It is a tidy metaphor as well as an engineering target. The wish to keep a flame safe in a windless jar until a new hearth is ready. Pieces of that wish already work in quiet, smaller ways. Frozen embryos resume their growth years later. Tiny tissues return to their tasks. Hypothermic patients rejoin the world. The larger picture is missing, and for now, belongs to story. Stories are not lies. They are sketches of edges, hints at directions. They sit next to possibilities and lean gently toward them. Far from the warm center, the solar system keeps its own galleries of cold. Worlds that rarely catch sunlight wait in modest arcs, and under some of their ice the ingredients of living chemistry stir. Europa circles Jupiter with a face like cracked porcelain, long rust-colored lines crossing a bright shell. The airless surface lives around 160 degrees C, and radiation from Jupiter's magnetosphere sweeps it hard enough that the ground is no place for a quiet walk. The interest lies below. Gravity kneads Europa with each orbit, tides in rock as well as in water, and that kneading makes heat. Under kilometers of ice, a global ocean likely moves, salt-rich and deep, more water than Earth holds on the outside. Heat from the tidal pull and perhaps from the floor, the kind of warmth that vents give to Earth's own deep seas could keep that ocean restless enough for chemistry to seek complexity. A smaller body, Enceladus, tucks near Saturn and outperforms its size in wonder. Its south pole is stitched with fractures that breathe. Plumes of water vapor, ice grains, and organic molecules fountain into space, so tall they feed Saturn's E-ring with snow. When a spacecraft dipped through the spray, it tasted hydrocarbons and salts, hints of water in contact with rock, a recipe that on Earth writes hydrothermal vents and the communities that gather around them. The surface sits around 200 degrees C, clean and bright. Underneath, the tug of Saturn and the moon's own flex keep an ocean from sealing shut. The plumes are not a metaphor. They are samples cast into space by a world that may be warm where it counts. Farther out, where sunlight thins to a suggestion, Pluto keeps time at about 230 degrees C. When a small, patient probe flew by, it found mountains made of water ice, plains of frozen nitrogen, a vast pale heart across the face, and textures that speak of recent change. Glaciers flowing, ices sublimating and settling, perhaps eruptions that move slush instead of lava. Pockets of liquid might survive at depth, warmed by slow decay of internal radioactivity and the good insulation of nitrogen and rock. The surface is not dead. It is quiet work done slowly. Life's resume on Earth lets these places feel less improbable than they once did. In the deep ocean, far from light, microbes feast on chemistry at vents where hot water meets cold sea. In Antarctic ice, cells wait and sip. In acid pools and alkaline lakes. In deserts that forget rain for years. In reactor tanks, life writes lines outside the warm green picture books. What life requires is not summer. It is gradients, energy moving from here to there in a way that can be tied to making and repairing. Under ice, gradients can be shy but sturdy. Minerals meet water. Tides strain rock. Chemistry finds a handhold. Cold helps by protecting complexity. Ice makes a roof. Darkness makes a privacy where ultraviolet light cannot unspool fragile bonds as quickly. The shield allows time to lengthen, and in long time, small odds multiply. The same patience that lets an amino acid assemble on a dust grain in a cloud, the galaxy's slow kitchen might let more elaborate compounds accumulate under a moon's shell, nudged by salts, rocked by tides, kept clean by the cold. Machines would need to be as patient as the places they visit. A cryobot could melt a long shaft through Europa's ice, carrying a tiny oceanographer in its belly. A plume sniffer could drift through Enceladus's spray and bring back grains to heat and analyze. An orbiter could map Pluto's nitrogen storms and search for subtle shifts that hint at a deep reservoir. The instruments would wear winter coats and watch their own warmth like a heartbeat, because the cold helps and harms in equal measure. Preserve too much heat, and you confuse your own detectors. Lose too much, and your hinges won't move. Balance, always, with the background at 2.7 K, whispering through space. If life is found under ice, it may be small and patient, cells that divide rarely, metabolisms that tick in slow motion, ecosystems measured in centuries instead of seasons that would not make them lesser. Slowness is a strategy, as sound is speed when energy is scarce. We would recognize the logic even if the shapes were new. Waste recycled tightly, sunlight replaced by mineral gradients, communities woven around a steady, quiet source. There is a softer echo in all of this. Suspended animation as a metaphor belongs as much to oceans under ice as it does to silver pods. Worlds can hold their breaths for long stretches and keep something tender alive beneath their shells. A moon can shelter an ocean the way a story shelters a hope. Cold is not just challenge. It is a keeper of time, a guardian of delicate work. Between a person in a pod that does not yet exist and a microbe drifting near a vent that might, the thread is the same. Lower the noise so the important signals can pass. Whether we aim to pause a body for a voyage or tune an instrument to catch a faint molecule, the method is one of patience and protection. Shade the light, smooth the temperature, avoid the cracks. The cold provides the stage. What steps onto it is up to chemistry and to us. If the idea still feels impossibly distant, rest for a moment on what is already in hand. Embryos that sleep and wake, tissues that vitrify and return, deep hypothermia that buys a surgeon time, a telescope that keeps itself colder than the night around it so that ancient warmth can be seen as light, a moon that throws part of its ocean into space for anyone with a net to catch. None of this is the full story of cryosleep, and none of it is fiction. The future may yet add a pod and a soft hiss. For now, the universe is already practicing with frogs, with ices, with moons, with our own careful machines, how to keep important things safe while the dark is long. Beneath the ice of Europa and Enceladus, the recipe reads like a secret kept in a dark kitchen. Liquid water to carry the ingredients, a steady source of warmth to keep them moving, and organic molecules to assemble with patience. If heat leaks up from the seafloor through vents where rock and water trade minerals, the chemistry could run without sunlight. On Earth, such vents dot the mid-ocean ridges like little cities, feeding communities that glow by chemistry alone. Bacteria sipping energy from sulfur and iron, pale crabs and strange worms thriving in a night that never turns to day. The power isn't starlight, it's the quiet bargain between hot rock and cold sea. If a similar bargain plays out under ice on another world, a slow and careful life could take root where no sky is visible. We don't have the answer yet, only good questions and the instruments to ask them more gently. A spacecraft called Europa Clipper is slated to sweep past Europa many times, mapping fractures, tasting the thin atmosphere, and reading the ice with radar, the way a doctor listens through a stethoscope. The goal isn't to catch a fish, it's to learn the water, its depth, its salt, its motion. On Enceladus, designs exist for machines that might fly through its plumes again, sample the snow it breathes into space, or even nestle on the surface and sift fresh frost for complex molecules before they sublimate away. Each step is small on purpose. Where the energy is scarce, arrogance breaks easily. Patience, in science as in life, goes farther. Cold worlds keep confounding the old habit of calling them dead. Pluto, so far from the sun that daylight is a rumor, turned out to have mountains of water ice, plains of nitrogen that flow like slow glass, and textures that change over years. Nothing about that landscape is theatrical. It's meticulous, like frost growing fern patterns on a window and then erasing them again. The lesson repeats across the outer system. Quiet is not the same as empty. Cold does not cancel motion. It slows it to a speed where you can see the shape. The most promising refuges for life in our neighborhood may not be warm deserts or red plains. They may be oceans with ceilings, dark seas under shells of ice where gravity's kneading replaces sunlight and chemistry writes its own hymns. And there may be many such places. Icy moons are common. Dwarf planets are plentiful. Shells and oceans seem easier to build than temperate Earth clones with tidy skies. If the basic ingredients gather water, energy, and time, life's odds might be better in the dim, protected rooms of the cosmos than on the bright porches. It's a humbling thought. Perhaps our habitat is the exception, and the norm is a whispering ocean, kept warm by tides under a roof of winter. That word cold wanders into another mystery that sounds dramatic and turns out to be precise. Cold, dark matter isn't cold like ice or dark like a cave. Dark means it ignores light, passing through the electromagnetic chatter without a greeting. We know it by its pull. Stars at the outskirts of galaxies whirl too fast to be held by the visible matter alone. Clusters of galaxies bend background light more strongly than their luminous contents can explain. Something unseen adds gravity and scaffold structure. Cold means slow in the early universe, non-relativistic, when clumping began so that this something could gather into seeds, pulling regular matter along to build galaxies and the long filaments that stitch the sky. Other tempos exist in the models. Hot, dark matter would have raced near light speed and smoothed away small clumps, leaving a universe too tidy for the thickets we observe. Warm sits between, a compromise sometimes used to tune small discrepancies between prediction and sky. But the leading portrait, the one that fits the background glow's fine modeling, the lensing maps, the galaxy surveys, is cold, dark matter arranging itself into halos like invisible cities, with luminous streets draped on top. We haven't met the particle or field that plays this role. Candidates have paraded by, WIMPs that almost never touch regular matter, axions that behave like a pervasive, delicate field, sterile neutrinos that ignore all but gravity. Detectors in deep mines listen for a single tap. Colliders look for a missing piece in the debris. So far, the quiet has held. Even so, the accounting is stark. Ordinary matter, the kind that makes bread, bones, and brass, adds up to a small share. The rest is dark matter, and something stranger, still called dark energy. The part we see is embroidery on a fabric we don't. A few have tried another route. Keep matter ordinary and change gravity's rules. These modified gravity ideas capture some galaxy-scale curves with clever mathematics, but they stumble on the vast web and the background's delicate pattern. The invisible scaffolding remains the most honest fit, not because it's romantic, but because it works. Simulations with cold, dark matter produce a cosmos that looks like ours when you turn the lights on. Clusters at the knots, voids in between, a lacework that matches the photographs. If a better idea arrives, it will have to sing as sweetly to all the data at once. Follow the line of cold farther out in time, and the story grows quieter still. The universe began hot and bossy. It's been cooling and spreading ever since. Entropy, the tendency for energy to even out, for differences to blur, has been climbing in the background like a slow tide. The end implied by that climb isn't a spectacular crash, but a room where everything is the same temperature and nothing drives anything else. No steep hills for energy to roll down, no free lunches for engines or stars. Heat death is an odd name for such a place. It is really the final cold, the point at which the cosmos has relaxed all its tensions, and only small, patient processes remain. That's a bedtime ending, not a battlefield one. A sigh, not a shout. For now, we live in the interesting middle, where gradients are abundant. Stars burn because gravity makes cores hot and envelopes cool. Planets radiate after sunsets. Black holes dine and ring. The second law doesn't forbid structure. It provides the reason for it. Things happen precisely because there are differences to spend. Over time, those differences soften. Galaxies will dim. The last red dwarfs will smolder on like banked coals for trillions of years, and then wink out. Matter will grow sparse, interactions rarer, and motion tilt toward rest. If that sounds bleak, remember how much beauty has already been borrowed from the same rule. Entropy gives us arrows for time, photos for memories, ice for roofs that shelter seas, and the pressure to find meaning while the lights are still warm. Between now and then, the cold keeps doing its graceful work. Under ice, it guards oceans from radiation and rash chemistry, letting molecules take their time. In labs, it pulls back the curtain on coherence and frictionless flow, teaching us how matter behaves when the noise goes down. In space, it preserves machines and records, holds telescopes steady, and turns the whole sky into a deep, clean stage where faint signals can be heard. Even the invisible architecture that shapes galaxies is called cold, for a reason tied to calm, not frost. Hold a few images in mind as the night continues. Europa's shell, crazed with lines like a hand-drawn map, and below it, an ocean that moves when Jupiter squeezes. Enceladus exhaling snow you can fly through and taste, Pluto's pale heart changing with seasons that last longer than civilizations. A map of the microwave sky that looks like silk under a lamp, telling us the universe's age with the confidence of a clock. A deep mine detector waiting for a single, soft knock from something that does not glow. A ring of superconducting wire holding a levitated magnet as if the world had grown a new rule. None of this is loud. All of it is precise. Cold is the steady metronome that lets the music keep time. It helps to know that most of the cosmos is neither fire nor fury. It is patient arrangement. Water under ice, gravity in long conversations, invisible mass laying out streets for galaxies to stroll. Entropy rising like a slow tide, while complexity surfs the waves it makes and then steps gently back. When you look at a photograph of an icy moon or a dim dwarf planet, try to see past the frost. Imagine the privacy such worlds create for chemistry, the way a closed door makes a room feel safe. Imagine the larger privacy granted by the parts of reality we can't yet touch, dark matter's hush, holding everything together, the final quiet implied by the second law. Cold does not mean nothing. It means room to notice. It means time to gather. It means a stage where small actors can be seen. And in that patient light, the universe tells a story that feels fitting for the hour. Beginnings tucked under shells, structures held by invisible hands, endings that arrive not as disasters, but as rest. Somewhere, a probe is already on its way to listen at Europa's door. Somewhere, a detector listens underground for a particle that may never knock. Somewhere, a telescope dozes behind a sunshield and wakes each day to look into longer yesterday. The night is wide. The temperature is honest. The cold keeps the page from smudging while we read. For now, the sky is still lively, galaxies brushing past one another, black holes sipping bright streams of gas, starlight traveling like warm breath on a cold pane. Entropy prefers imbalance, and the cosmos obliges with gradients to spend. That bustle will thin. Roll the clock forward through a hush of trillions upon trillions of years, and the bright actors step off stage. Big stars live fast and leave dense remnants. Small red stars linger, steady and frugal, but even they will finish their fuel. What remains from the long burning is a quiet population of embers, white dwarfs cooling like stove coils left off, neutron stars holding their gravity-tensed cores, black holes rounding out the cast. Given enough time, the embers fade further. White dwarfs slip into perfect dimness. As black dwarfs, the light gone, the heat given to the dark. As the last new stars fail to form and the old ones wink out, the night grows sparse. A galaxy becomes a memory of itself, a geometry without glitter. Even black holes once thought eternal feel the slow discipline of Hawking radiation, seeping energy grain by grain. The evaporation takes longer than words can carry, but the direction is firm. Mass ticks down, horizons retreat, the deepest wells empty into a quantum mist. What lingers after such patience is thin, a diffuse stream of particles and weary photons coasting through an expanse so large that distances become abstractions. Temperature falls toward absolute zero and stops just above it, not with a crash, but with a long glide. No steep hills remain for energy to roll down, no fresh gradients to power chemistry or weather or stars. This is heat death poorly named, because it isn't a blaze. It is the final cooling, the spread of everything, until nothing can drive anything else. Equilibrium is the word physics uses. Stillness is the feeling. This is not tomorrow's news. The endgame plays on timescales that make ages sound like afterthoughts, star deaths across trillions of years, black holes whispering themselves away over numbers so large they read like lullabies of zeros, a Google, years and beyond. Other endings have been sketched. A universe could reverse and fall into a big crunch if gravity had more to say. Or expansion could race so fast that the Big Rip unthreads even atoms. Measurements today point to the quiet fade instead. There's a strange mercy in that portrait. No calamity, no sirens, just the same principles that made stars ignite and ice melt, carrying the story to a soft close, consistent to the final page. Some imagine new bubbles of space-time budding from the emptiest dark, fresh beginnings sparked by quantum chance. That's a thought to tuck near the pillow, not a promise. What we can say with steadiness is that the present universe moves toward calm, while the future cools by itself. We have learned how to borrow a little of that quiet here. The coldest places do not float only in space. They hum in laboratories, where lasers draw slow nets around atoms. In these rooms, researchers turn motion down close to nothing, billionths and even trillionths of a degree above absolute zero. At such stillness, matter stops behaving like a crowd and starts singing as a choir. Quantum effects, usually blurred by thermal chatter, become the main script. Clouds of atoms are coaxed into Bose-Einstein condensates. Not many voices, but a single shared wave you can tease and measure by the patterns it draws when released. It isn't about trophies, it's about clarity. Each fraction of a degree we shave away removes noise and leaves the grammar of the world easier to read. The path to that quiet is layered and gentle. Laser cooling meets atoms head-on, with light tuned so that each photon gives a nudge against motion. Magnetic and optical traps hold the slowed cloud as if in cupped hands. Evaporative cooling lets the most energetic atoms slip away, lowering the average energy of those that remain. Stack these steps carefully and temperatures fall into the nanokelvin realm, where motion is a suggestion more than a fact. In that environment, phenomena with beautiful names take on practical lives. Superfluidity, flows that forget friction, superconductivity, currents that travel without loss, coherence that lasts long enough to build better clocks, steadier sensors, and qubits that keep their delicate superpositions while the outside world pounds at the door. Whole institutes have turned their lights down for this work. Teams at places like Gila and NIST use atom interferometers, matter wave analogs of optical instruments, to feel tiny changes in gravity and time. A cloud split and recombined becomes a ruler for the unseen, measuring shifts so small they read like a whisper under a whisper. In orbit, the International Space Station carries the Cold Atom Lab, where microgravity lets ultra-cold clouds hang longer, untroubled by sag. The extra seconds are a gift. More time to watch a condensate, drift and ripple. More time to test how quantum objects fall. More time to push equivalence between mass and motion until the numbers either hold or hint at a crack. Even the places famous for smashing particles have corners where the goal is to slow them instead. At CERN, traps and cryogenic fields tame antimatter long enough to ask basic questions. Does antihydrogen fall like hydrogen? Do its spectral lines match? Holding such fragile guests requires temperatures low enough that motion cannot ruin the meeting. It is like balancing a snowflake in a warm room with nothing but shade and patience. What do we learn from so much quiet? That heat is indeed only motion, and when motion eases, patterns appear. Electrons pair and glide. Lattices carry current without grudge. Fluids slip through narrow places as if walls were rumors. Information can be stored in ways that warmth would smear, transported without leaking away as waste. The rules we teach in classrooms resolve into detail. Uncertainty still hums at 0-point levels. Phases matter as much as positions. And interference is not decoration, it is the plot. There's a wider echo in this. The same cooling that reveals new states of matter also keeps telescopes honest. A mirror, cradled in cold, sees farther in infrared because its own glow doesn't drown the sky. A detector chilled deep reads the faintest galaxies not as noise but as signal. The vacuum that chills spacecraft is also the preservative that lets them last. Warmth managed carefully inside, emptiness outside, doing what it does best, nothing at all. So the story holds together from the smallest rooms to the largest futures. Entropy rises and uses difference up. Stars spend their fuel. Black holes thin to radiation. In the end, the universe leans toward a smooth, cold sea. Along the way, in the middle where we live, we use the cold as an instrument. We ask matter to show us what it can do with distractions stripped away. We build clocks that won't drift for longer than civilizations, sensors that read the pull of a passing cloud, circuits that carry current with no tax, computers that step haltingly for now into a logic that can hold many maybes at once. Each of these needs a winter, the literal cold of a cryostat, the engineered shade of a sun shield, the quiet of a mine where cosmic rays cannot shout. Imagine, for a breath or two, how these images rhyme. A white dwarf dimming for ages until its light is only memory. A black hole taking eons to give its hoard back to space. A cryostat lowering a cloud of atoms until they decide to act as one. A telescope sleeping behind a silver sail and waking to catch ancient warmth as light. None of this is hurried. None of it is loud. The universe is practicing a slow art, and we have learned to listen by slowing our own experiments to match. We may never touch absolute zero, just as we may never see the universe's final evening. Limits can be kind. They keep the game interesting. Each step toward perfect stillness is not a failure to arrive, but a chance to hear more clearly. Even if the last page of the cosmic book is a blank white, cooled nearly to nothing, the pages before it hold galaxies, oceans under ice, superfluids creeping up glass, magnets floating above rings, and the pattern of a background glow stretched to a gentle 2.7K. The same rule hums through all of it. Where differences exist, stories unfold. Where differences fade, stories rest. Between those two, we study, we build, we cool, and we learn quietly, carefully, and just warm enough to keep turning the page. Each record-setting chill feels less like a stunt and more like a door that opens without a sound. Strip motion down, and hidden symmetries step out of the wings. Lower the noise, and small truths speak clearly. The coldest experiments are really exercises in stillness, precision, ways of asking matter to tell the truth with fewer interruptions. They're reminders that revelation isn't always a flash or a roar. Sometimes it's the hush after a breath, when the page stops rustling and the words stand on their own. Imagine a universe that has spent its brightness and come to rest. Not a wreckage, not a battlefield, just a room where every light has softly faded and nothing urgent remains. No blaze of stars, no engines of fusion, no gas clouds curling toward ignition. Temperature has slid down the scale until it finds the floor physics will allow. Space is vast and expanding still, but the motions inside it have thinned into almost nothing. It is not chaos. It's a tidy, quiet, like snow after the last footstep. In that ultimate cool, the galaxies no longer turn. The last red glow of the last small stars has gone gray. Black holes that once ruled the centers of galaxies have finished their long evaporation, returning their hoard to the faintest drizzle of radiation. What remains are sparse particles and tired photons drifting through a darkness that isn't angry, only wide. Entropy has done its simple, patient job. Spread energy, wash out contrasts, let differences relax until there's nothing left to spend. Life, at least as we know it, needs imbalance, the way a sail needs wind. Warm against cool, high against low, a gradient to push against, and a place to send the waste heat when the work is done. On Earth, the relay is obvious. Sunlight into leaves, leaves into sugars, sugars into motion and mind. Without a slope to slide down, the relay can't start. A perfectly even universe offers nowhere to lean and nowhere to go. Even a being that could hoard energy for epochs would eventually finish its candle and join the quiet. The thought experiments that imagine flickers of life, awakening every quadrillion years on quantum scraps, are beautiful in the way a mirage is beautiful, meaningful to think about, not something you can drink. Still, this final cool isn't a tragedy, it's a completion. A cosmos that once burned with extravagance has kept its own rules faithfully, from the first bright minutes to the last whisper of motion. The end is a rest, not a defeat, a stage cleared of scenery after the last bow. Stars told their stories. Galaxies moved in slow choreography across impossible distances. Gravity, light, and time played their parts without missing cues. When the curtain falls, it's with courtesy. Taken to its farthest edge, cold becomes a way of seeing, not a threat. Without the glare of heat, the scaffolding of reality is easier to trace. In that imagined quiet, you're left with pure relationships, distance, curvature, the geometry of a fabric that no longer stirs. The questions change flavor. What does time mean when nothing changes enough to mark it? If no atom vibrates, what is a second? If there's no flow of heat, what becomes of before and after. These aren't riddles with answers, so much as invitations to sit with the shape of being when doing is finished. Beauty doesn't pack up when warmth leaves. It shifts register. There's the grace of symmetry stretched over vastness, the dignity of particles content to drift, the stubbornness of gravity holding its soft influence to the last. There's a gentleness, too, in an ending that refuses to perform. Winter doesn't announce itself. It accumulates. First a hush, then a frost, then a plane of quiet you can cross without a sound. The universe, in this telling, doesn't rage. It drifts into composure, all of which loops back to the moment you occupy now. It is modest on the cosmic calendar and lavish in experience. Stars still burn, oceans trade heat with wind, leaves translate light into sugar. Circuits warm the tips of your fingers. Your chest rises and falls in air that learned its currents from the nearest star. The contrast that life needs is everywhere you look. The improbable warmth is all around. The more time you spend with the cold's long horizon, the rarer this warmth feels, the more it begins to glow with the value of anything fragile and temporary. Cold, real cold, isn't a villain in that appreciation. It's perspective. You can walk through the Boomerang Nebula in your mind and understand why it outcools the microwave background. You can picture intergalactic space, where temperature is a number and matter is a rumor, and feel how that background hum at 2.7 K sets the floor for everything. You can rest a hand carefully on the sunshield of a telescope that needed to be colder than night to read the faint warmth of ancient galaxies as light. You can stand in a lab and watch a cloud of atoms act as one thing instead of many. Each is a way of saying that cold doesn't erase meaning. It clears the air. We've visited oceans under ice where tides replace sunshine, plumes drawn into space by small moons with big ideas. We've watched helium refuse to behave like a respectable liquid, climbing glass and flowing without friction. We've followed electrons that, when given enough quiet, pair up and glide through a lattice without loss. We've noticed that most of what holds galaxies together doesn't glow at all, and that its coldness is a measure of calm more than temperature. We've walked the temperature ladder from lava to background and looked over its railing at absolute zero, the horizon that physics permits you to approach but not cross. Each step has been a way to learn how the world behaves when haste is taken away. The further the noise recedes, the sharper the patterns become. Entropy still rises, gradients still flatten. Yet within that general drift, the cold draws out forms that warmth hides, a condensate that interferes with itself, a superconductor that levitates a magnet, a superfluid that declares its rotation in neat rows of tiny vortices. These aren't ornaments, they are grammar. The clarity of the cold is proof that there was coherence folded into matter all along, waiting for a chance to be legible. There's comfort, too, in the limits. Absolute zero stays beyond reach, the same way the last page of the cosmic book stays beyond our era. The third law is a boundary written like poetry. You can go farther and farther still, and yet there will always be one more step between you and perfect stillness. That unreachability spares the world from brittle absolutes. A little zero-point tremble is built into the fabric, an insistence that perfect silence is a story device, not a state of nature. It's a good rule. It keeps clocks honest, crystals alive to vibration, and curiosity supplied with work. If you carry anything from this tour of winter, let it be the double vision it offers. Cold shows you how things end and how things are built. It is the future equilibrium and the present microscope. It sets the boundary conditions for life and, paradoxically, hides likely habitats under ice. It preserves, reveals, clarifies, steadies. It asks for patience and pays in understanding. Some nights, thinking about these distances and temperatures, the mind loosens its grip in the best way. The room becomes a kind of observatory, the pillow a quiet shoreline, the breath a tide. Scale stretches and the numbers lose their sharp corners. You can imagine the long evening of the universe without fear because it is so slow and so polite, and because your own evening is specific, warm, and held by familiar walls. You can look up from wherever you are and know that the same chill hum of the background connects your ceiling to the deepest darkness, and that in between are stories you've touched, moons with hidden seas, telescopes that sleep in shade, labs that lean close to the edge of motion. And listen, there's a lovely paradox in how cold teaches gentleness. Lower the temperature and matter becomes considerate. It shares phases, stops shoving, holds patterns without argument. Lower the temperature, and thought becomes considerate too. It slows, observes, chooses better words, sets a careful pace. The science and the mood agree. The universe is vast and will be vaster. The end will be quieter than any myth. The present is warmer than it needs to be, and kinder than it could be. And small, attentive steps, cooling a cloud, wrapping a spacecraft, shading a mirror, counting a ripple, can carry you a long way. For now, the world around you still hums with useful difference. Engines turn, leaves darken and sweeten, snow melts from eaves. A kettle argues itself to a boil. That is the stark miracle. On a planet with thin air and a good star, gradients are plentiful, and time runs at a human speed. The future's final hush doesn't take that away. It lends it a frame. The contrast makes the present more luminous. Settle into that thought. Let the long arcs of temperature and time fold themselves back into a single room and a single breath. Somewhere far above, a satellite drifts in shadow, its instruments kept cold enough to hear ancient warmth. Somewhere far below, a detector rests in rock and waits for a particle that does not shine. Somewhere at the edge of a moon, frost falls into a plume and becomes a trail a spacecraft can follow. Somewhere in a lab, a cloud of atoms sighs into one shared wave, and the graph on a screen writes a delicate proof that stillness can be made. And here, the room grows a shade dimmer. The last complications tuck themselves in. The mind sets its instruments quietly on the table and listens to the soft engines of the body keep time. The universe outside is large and, in the very long run, heading for rest. The life inside the room is small and warm and, for now, wonderfully busy. Fade out, a softer breath, a longer pause. The story thins to a whisper. Winter holding the page steady while your thoughts drift. A low hush that widens, and then, like snow settling in a field where no one walks, the sound goes gentle, gentler, gone.